This is number 21 on page 495, where we're asked to determine the 5 fifth roots of j. So, like the previous problem, number 20, j in x plus yj form is just 0 plus 1j. And as we saw in number 20, the point 0, 1 is right here at 90 degrees. So theta is 90 degrees. That point 0, 1 is one place away from the origin of the complex plane, so r is 1. And n is the roots we're finding, and in this case we're finding the fifth roots, so n is 5. So when I go to write the formula that I'm going to use to find these 5 fifth roots, I'm going to substitute those values in for theta, r, and n. So z sub k will equal the nth root of r, which will be the fifth root of 1, times, and I'm going to find just the first theta over n. So times the cosine of theta over n, which would be 90 over 5, plus I times the sine of 90 over 5. This will be my first fifth root of j by substituting 0 in for k, because 360 times 0 is 0, and anything, so adding 0 will not change the 90 over 5. So when I divide 90 by 5, I get an angle measure that I don't recognize as a critical value on my unit circle. So the fifth root of 1 is 1. I get 18 degrees for my angle measure. Cosine of 18 degrees plus I times the sine of 18 degrees. Because I don't recognize 18 degrees as one of my critical angles on the unit circle, I'm not going to be expected to give its exact value. So I can use my calculator with its mode in degrees and just type in cosine of 18 and then sine of 18. So my first fifth root, of j is 0.309 plus I times, oops, I have that wrong. Cosine was 0.951 plus I times the sine of 18, which was 0.309. Or j, I'll use j. Okay? Now, to figure out what my next angle measure is going to be, I need to merely look at this portion of this formula and plug 1 in for k, because that's going to be my next value of k that I use in this formula. Well, 360 times 1 is 360. When I divide by n, which is 5, 360 divided by 5 is 72. So all of my angles that are going to be used to find my fifth roots of j are going to be 72 degrees apart from one another. So to find z sub 1, I'm going to need to take that fifth root of 1 again, which is still 1, and take my 18 degree angle and add 72 degrees to it. That's 90 degrees. Cosine of 90, if I look at my unit circle, here at 90 degrees, I know my coordinates are 0 and 1. Cosine is the x-coordinate, so cosine of 90 degrees is 0. Sine of 90 degrees is the y-coordinate. So my second fifth root of j is 0 plus 1j. To find my third fifth root of j, I'm just going to need to add 72 degrees again. So it'll be 1 times the cosine of 90 plus 72 degrees plus I times the sine of that. The cosine of 162 degrees is negative 0.951 The sine of 162 degrees is 0.309. I or j. There's my third fifth root of j. To find my fourth, I'm going to need to substitute, I'm going to need to add 72 degrees again to my previous angle measure. So 162 plus 72 is 234. Well, the cosine of 234 is negative 0.588. And the sine of 234 is negative 0.809. To find my fifth root of j, I'm going to need to add 72 degrees to my previous angle measure of 234, excuse me. And I get 306 degrees. Well, the cosine of 306 degrees is 0.588. And the sine of 306 degrees is equal to negative 0.809. There are my 5 fifth roots of j. The first one I got by subbing 0 in for k. The next I got by determining that the value of 360 over 5 is 72 degrees, so I added 72 degrees to my previous angle measure. I added 72 degrees to my previous angle measure again, and again, and finally the last time.